Hi everyone, welcome to another session of Code with a Friend. Today is another lighthearted session, so what I'll try to do is continue my learning of Rust. Um, we'll just do a quick recap of what we did in our last session. So in our last session, we were trying to create a guessing game by following the instructions that the official Rust language documentation has. The few things that we learned about the language is how to create a project using Cargo, how to build a project. Um, to be honest, I did not like too much to know about the packaging before we actually learn about the language, but we also learned few things. For example, how to import packages. For example, like stdio, which contains the input-output utility, the rand crate. I think how we can have dependencies of crates, um, how we can use traits. So there are like a lot of terms were thrown around in our last session. We did not go into too much details of each of them because the documentation sort of wanted to get familiar with those terms first and not to get into too much detail of them. And we followed the same pattern. So let me see if I can just run it. So what basically, let me quickly go over the program just to recap myself also. We did a println. So this is a println macro with a exclamation mark after the function name. We asked to guess the number. The secret number we get by getting a range between 1 to 100. Then we ask the user to input a guess. We get the guess in a string number. We do a mutable reference thing. So this is like a reference, memory reference, which we haven't gone into detail yet. Then we did a parsing of guess. So we did like a trimming, then a parsing. After that, if it is fine, every kind of parsing gives like a result object sort of, which has these two operations like okay or error. You handle okay in a certain way, which is like a success kind of thing, and error you mention like how to recover from the error. And at the end, we mention what is the guessing that happened. Uh, we also do with the comparison, and then there is like a match that happens. So we have to define a match expression. If it matches with a particular expression, then we define what to do in that case. Um, this seems pretty much, I think, quite in line with a lot of popular languages. Like there are many things that I can see here from Scala, even though like I don't know too much about Scala. Probably that could be one of our sessions, like we could learn about Scala there. But for example, this match expressions traits something which I remember. Maybe I saw in Scala, but I could be wrong. Anyway, that's I think what our program that we had written last time. And if we just do a cargo run, so now is our guessing game has started. So typically we do like a binary search thing. It's too small, so I'll go up. It's too big. I'll come in between. That's like 67, and that is right. Let's run again. Start again from 50. Too big. Go down. 25. Too big. Go below. Too small. 20. Too small. So it's between 20 and 25. Let's say 23, it's too big. So between 20 and 23, 21, too small. So 22 is the right answer. So yeah, I think the game works pretty well. Now let's move on to the next option. Okay. Learn about variables, basic types, functions, comments, control flow. These are the things that any language needs. These foundations will be in every Rust program, and learning them early will give you a strong core to start from. Absolutely makes sense. I think we should know what are the data types are, what is the control flow. As mentioned in the storing values with variables section, by default variables are immutable. Yeah, I think this is something I mentioned vaguely, but we have to explicitly define if a variable is mutable, otherwise all variables are immutable by default. This is one of the many nudges Rust gives you to write your code in such a way that takes advantage of the safety and easy concurrency that Rust offers. So this is the one point I also mentioned. If you have immutable states, then concurrency becomes much easier because uh, state management is a key problem for concurrent programs. We can go deeper into more into that in one of the sessions. However, you still have the option to make your variable mutable. Let's explore how and why Rust encourages you to use immutability. When a variable is immutable, once the value is bound to a name, you can't change that value. Let's read this. Okay. Cargo. Okay, so we want to create a new project probably. Cargo new variables. Okay, so we have the variables. Now we'll go inside that. Let me close this VS Code window. Okay, so I'll go here. We'll put some code here. So what the tutorial says is let x be is equal to some value, and then we'll just do a println the value of x is okay. If we modify x, then we do again a println. So my hunch is this should throw an error because this is clearly says, not this, but usually Rust clearly says that the variables are immutable, and we are not defining a mutable variable explicitly here. So what we can do a cargo check that usually just compiles the program and checks for correctness without generating the binaries. So it's wrong. So another thing we really liked, I personally liked a lot, is the way Rust compiler actually tells. I had heard before like Rust compiler really tries to teach you and finds like different kinds of ways to figure out what the error is and how you can possibly fix it. So as you can see here, it says cannot assign twice to immutable variable x. First assignment to x happens here. Consider making it a mutable. So it suggests that potentially you can try this. So if we try this and just do a cargo check, that works fine. So the compiler is really teaching us there. That's the same error it shows. I guess that's the explanation that we have here. Once we do a mutable, now I think that works. And if I do cargo run, that actually runs also. So yeah, I think the question obviously comes if like all variables are immutable by default, then all of them essentially becomes constants, right? Then what's the difference? So like immutable variables, constants are values that are bound to a name and are not allowed to change. But there are a few differences between constants and variables. You're not allowed to use mute with constants, and just immutable by default. They're always immutable. You declare constants using the const keyword instead of the let keyword, and the type of the value must be annotated. We'll cover types and type annotations in the next data types. So don't worry about, okay. Yeah, I think this is another thing which we noticed. Constant needs type annotations, but variables do not need. I think they're trying type inference here, seems like, because I don't think Rust is dynamically typed. So if I have, let's say, mutable variable here, then I try to assign a different data type. Should it? I mean, I would be very disappointed if this works. Yeah, so there is a mismatch type, right? So it says like expected due to this value, expected integer found string. Even though we did not say what the type is based on the first assignment, it just worked. If we had 5 here, then probably it would have worked fine. Constant declarations, yeah, let's go. So I think constant declarations, we can do like type annotations like this. So if we want to specify a constant, something like this, 3 hours in seconds. That's like an unsigned 32-bit integer. 60 multiplied by 60 multiplied by 3. Cargo check. What does it say? It's never used. Yeah, it's unused. So it's a warning, essentially. Excuse me. But I think this shall work. Let me grab some. But I believe if we intentionally make some mistakes, the compiler should be able to tell us. For example, if we don't specify the type here, yeah, it says like it should provide that. And it actually suggested like it should be I32. What happens if I have like a string here? Would it suggest accordingly? Yeah, that's I think quite smart. So basically, based on the inferred type, uh, the compiler suggests you to make changes. Like for example, in this case, I can add like this kind of thing. Now it becomes like a warning. I can still print it probably. Um, Something like this. So now I guess the use is there and the check works fine. So this is I think fun. Um, okay, so the compiler is able to evaluate a limited set of operations at compile time, which lets us choose to write out this value in a way that's easier to understand and verify. Rather than setting this constant to a value this, Rust's reference section on constant evaluation for more information on what operations can be used when declaring constants. Sure, constants are valid for the entire time a program runs within the scope of in which they were declared. This property makes constants useful for values in your application domain that multiple parts of the program might need to know about. Naming a hard-coded value is used throughout your program as constant is useful in conveying meaning of the value. Yeah, I think that's general purpose. I think in most of the languages you should have a separate naming conventions for constants. As you saw in the kissing game tutorial, you can declare a new variable with the same name as the previous variable. Yeah, this is I think something which came to my mind as well. Somehow I did not bring it up. Okay, let's see. I think it's not there here. So if we go to the guessing game and just get the so yeah, so we had um, two variables with the same name. That's I think struck my mind also. Like, how is this happening? Like, you have a variable guess, and then you are doing this with the same name. I didn't know like yeah, I mean of course they had done it intentionally so that we notice, but that is sort of unique, right? So I mean if I do here, I have to go back to variables cargo check. So yeah, variable does not need to be mutable. Okay, that is unique. So are they breaking the entire scope into multiple parts? It actually works. Rustaceans say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. Okay. Overshadows the first taking any. Okay. That is unique. So the declaration, the second time declaration, the compiler sort of ignores that. If you already have a variable with the same name, so what happens in other language, like in C and something? So you can't declare, but you can assign different values to it. So essentially here it assigns different values. Like if I run it, it'll just give me an update value for the same variable. But the compiler also doesn't complain like, hey, you already have declared the same variable before, which is a unique property. Um, Minds x to a value of 5, then it creates a new variable x by repeating let x, taking the original value, adding 1 to it. Within the inner scope, created the curly brackets. Yeah, I think this scope thing is actually interesting. Let me copy it over so that we can quickly see what's happening. Just throw it clear. Okay, let's do a cargo run. Variable x. Okay, so that's I think natural scoping mechanism, which makes sense. In whichever scope that variable is defined, it will just work there. I believe, yeah. And similarly, if you don't declare it, just modify the same variable, even though in this case you can't modify it because it is not mutable, but you can define it to be mutable. So this is, I think, an interesting property. The same variable can be immutable and mutable throughout the life cycle of the program. Like this actually works fine. So the variable is immutable initially, then it becomes mutable. And if I do a cargo run, now its variable inside the scope and outside the scope is same because I am now modifying the same variable. It's not a different variable. This is interesting. Shadowing is different from making the variable as mutable because, yeah, exactly. So I think the one that this example showed, it's just, I mean, that's how shadowing happens. But here it is becoming mutable explicitly. The difference between mutable and shadowing is because we are effectively creating a new variable when we use the let keyword again. We can change the type of the value, but we use the same name. For example, our program asks user to show how many spaces they want between some text. We want to store the input as number. Sure. Okay, okay. Oh, okay. Um, Excuse me, I think I just got a bit cold today. So yeah, what I was discussing is basically if you have like a string and you can also change the same variable to hold a different value. But that doesn't happen if the variable is mutable. Then it becomes problematic. Yeah, now I think we understand that. Now let's go to data type. Every value is of a certain data type, which tells Rust what kind of data is being specified, so it knows how to work with the data. Makes sense. Rust is statically typed language, which means that it must know the types of all variables at compile time, usually infer what type we want to use based on the value and how we use it. In cases when many types are possible, such as when we converted a string to a numeric type using parse in the comparing guess game. Yeah. So yeah, something like this. So we had like a string, then we did a parse and expect. So this expect, when there is an error, it'll just print that to the yesterday IO, the standard error, standard out. So we have this Guessing game, it's not used. What is it saying? If this is intentional, unused. Okay, if this is intentional, we can just prefix it. Oh, so we can add a prefix underscore and it becomes, all the unused variables become valid in the eyes of compiler. So a lot of these are like compiler directives. If we don't add the U32 type annotation shown in the preceding code, REST will display the following error. Yeah, let's see. If we don't add it, what will happen? Type annotations needed. Interesting. Why? Compiler needs more information which type it wants to use. But it doesn't need anything if I just specify 42 or 3, whatever, 1. Oh, yeah, I think that is, the semicolon is missing. But when we just do parse, type annotations needed, where the type for type parameter f is specified. This is interesting, right? Yeah, let me just try out this Rust C. Explain error 282. So the compiler could not infer a type and asked for a type annotation. Okay, okay. It's I think the reasoning is same, like the compiler type inference failed. So for example, if we have hello, cars, reverse, collect, this error indicates that the type inference did not result in one unique possible type and extra information is required. In most cases, this can be provided by adding a type annotation. Sometimes you need to specify a generic type parameter manually. Collect method on iterator. Just generate front iterator. Hello cars, reverse, collect. Another way to provide the compiler with enough information. Specify. So yeah, what if I just give enough information? Yeah, if we provide like these so many things which I don't fully understand everything now. Uh, Cars, reverse, collect, vector character. That works. Okay. So if the compiler is able to understand, it will say it's fine, but otherwise it will ask you. So what are the things? I think integer that's yeah, this is something I also heard about. The good thing about Rust is you don't have to memorize like, okay, int is 32 bits, then long will be 64, then I can have like long int, something like that. Is long 64? C integer data types. Int is 2 or 4 bytes, right? So 16 or 32 bytes, unsigned int is 2 or 4, short is 2 bytes, unsigned short, yeah, long is 8 bytes, so it could be 32 bytes, unsigned long is 8 bytes. No, so long is 32 bytes then. Then long is 64 bytes. Long. Float. What about float? 32 bits. Yeah, what I'm saying, I'm telling 64 bytes. It's actually bits, 64 bits. Floating point type. Yeah, anyway. But this is, I think, quite nice. So it's pretty simple. Unsigned is U, signed is I8 or U8. Similarly, we go. Yeah, each variant can be either signed or unsigned and has an explicit size. What if let's say I have a variable does it always assume it will be an unsigned value? I don't think so, right? V is assigned but never used. How do we know a type of variable? Is there any like type of kind of thing? So decimal, okay, decimal. Oh, this is unique. And then we have hex, then we have octal, binary, byte. How do you know which type of integer to use? Defaults are generally i32. Integer overflow. If you have a variable of type u8 that can hold values between this, you try to change the variable to a value outside of that, integer overflow will occur, will result in two behaviors only in compiling in debug mode. Checks for integer overflow, cause your program to panic at runtime. If this behavior occurs, uses the term panicking when a program exits. Unrecoverable error with panic. When you're compiling in release mode with minus minus release flag, does not include checks for the integer overflow that cause panic since the overflow occurs. Rust performs tools complement wrapping. In short, value is greater than the maximum value the type can hold, wrap around to the. Okay, this behavior I think is very specific. So in release mode it will do that, but in debug mode it actually. So which is nice, which means in you can have two versions. You can do like testing and expose all these errors. Then release mode language sort of suppresses this, so you don't see that crash or those kind of things, but makes sense. Floating point f64, f32. Default is f64 because in modern CPUs it's roughly the same speed as f32, but is capable of more precision. Makes sense. All floating point types are signed. Makes sense. Numeric operations, addition, subtraction, multiplication, division, truncated division results. Yeah, similar remainders. I think that is fine. Boolean type, okay. Boolean type, true and false. The main way Boolean such as if expression in control flow. So we can also do like this. I guess like this is like a character. So specify character literals with single quotes as opposed to string literals which use double quotes. Character types is 4 bytes in size, represents Unicode scalar type, which means it can represent this. Compound types. Compound types can group multiple values into one type. Rust has two primitive compound types, tuples and arrays. Primitive compound types. This is interesting. A tuple is a general way of grouping together a number of values with a variety of types into one compound type. Fixed length. Once declared, they cannot grow in size. Comma separated list of values. So we can decide a tuple like this. Okay. What if we don't specify the types? I believe they should still work. Right? Should work. No, oh no, I think that's because of that. Um, so it works. How do we access the variables? Printing the value of y cannot be formatted with the default formatter. How do we do that? The trait std format display is not implemented for integer float string. In format strings, you may be able to use to specify this or this instead. Is this what it's saying? Expected comma. Awesome. So this is amazing. Like I can just try out different things and the compiler will tell me what to do. Nothing better than that. Program creates tuple, binds it to another variable tuple. How can I access individual values like dot, something like this? Interesting. Just like indexing. Array type. Another way to have a collection of multiple values is within an array. Unlike a tuple, every element is an array must have the same type. That's interesting. Yeah, of course. Arrays are useful when you want to have your data allocated in the stack rather than the heap. We will discuss the stack and heap more. Um, yeah, I think just to clarify, I think my understanding. So yeah, how the memory layout looks like. So there are a few components which we have in the memory. Stack stores the local variables. Heap will have dynamic memory for programmer to allocate, and data section which will store global variables separated into initialized and uninitialized, and then text stores the code that's being executed. In order to pinpoint each memory location in a program's memory, we assign each byte of memory as an address. The addresses go from 0 all the way to the largest possible address depending on machine. As the figure below, the text, data, and heap segments have low address numbers, while the stack memory has the higher addresses. Right, so in a program like this, oh, this is beautifully illustrated. A is here, B is here, C is here, B is here. Then we have another A. So the main memory will allocate something, then you get another value, but the previous value is still there in the stack. So when you go out of the scope from hello, it will basically pop out. So I think it's pretty evident, right? So we have A, which is uninitialized. That's the first A that we have. Then we have B, which is -3. Then C is 1, 2, 3, 4, 5. There's like an integer pointer, which has the address of B. And now I'm calling hello function. So the hello function has an declaring a new variable A, and it's new scope. So you can define a new variable there, and that is fine. And then you just return at the end you just return the value a, and that I think should have a variable inside here called d. So after that, when you come here, allocate D for main and store 100. And now I guess like this is basically pointing to this location B. Deallocate the stack memory of main and return 0. So after that, we will have this. Um, what is this state? Allocate variable A for main. Okay, I think it's showing the same thing step by step again. Yeah. So that's I think for stack. Heap is, we saw the functions that cannot. So stack I think for local variables which are within scope. Heap is anything that we are allocating, and that's our heap memory from where we can have um, reference to a memory location which can be accessed from different places. That's I think my understanding. Like you can say new integer, new cube, something like that. And from different places in the stack, you are accessing this heap memory. Um, yeah, but you have to be aware to clean this up because stack memory will be cleared as your scope ends, but heap memory will not be. So you can potentially, and that's how I think the memory leaks happen. So whenever we allocate something but we forgot to deallocate, either our compiler or the runtime option will have some kind of checks, which we do not have mostly for C. So if you forgot to free that memory, that memory could potentially leak to other applications, and other applications can read data from there. So yeah, cool. I think we diverged a little bit, but just to understand, I think refresh my own understanding of stack and heap memory there. An array isn't as flexible as the vector type, though a vector is similar collection type provided by a standard library allowed to grow or shrink in size. If you're unsure whether to use an array or vector, chances you should use a vector. Makes sense. Chapter 8 for vectors. Yeah, so I think this is like a array of string, write an array types. Okay, you write an array type using square brackets with the type of each element as semicolon, then the number of elements. Okay, this is unique. You can also initialize an array to contain the same value for each element by specifying the initial value followed by the semicolon. Oh, this is interesting. So the array name 0. So if I have like a an array which is like all zeros, I don't know like how to print this, how to do indexing. Okay, indexing is the same. So I just do just this kind of loop unroll thing. Can I do uninitialized array? Is it always initialized to 0? Something like that. This I think should be fine. And it's all 0. If I just have I32 5. First of all, is this a valid expression? It's not, right? Because it's not initialized. So that's I think one thing I have seen. Like you cannot declare without initializing. You don't need to specify the type. The inferencing system will understand that. An array is a single chunk of memory of a known fixed size that can be allocated to the stack. Indexing like this. The variable named first will get the value 1. Sure, invalid memory access. Enter an array index. Text will do a read line and then trim. Okay, and then if it's outside, the value of the index is outside. So index out of bounds. guards, it's a runtime error. Makes sense, that's standard. Functions, I think we have already started using functions. It's pretty lightweight, just says fn. Um, at least in C-like languages, you don't have to specify that this is a function, but here you have to. I'm sure there is some reason for it. Python and all, you have to specify def for function. Most important, the main function, which is entry point for programs, the function fn keywords. Rust code uses snake case as the conventional style for function and variable names, which I also like. Snake case is good, in which all letters are lowercase and underscore separate words. Makes sense. Yeah, let's just try it out. Cool. Yeah. So entering fn, I think that's standard, nothing. So parameters we can, in the same way, probably colon. And the type, I guess you have to provide a type always, right? Expected one of colon at or. Okay, I don't know what this is. Anonymous parameters are removed in the 2018 edition. CRFC 1685. Okay, so probably before 2020, 2018. Yeah, deprecate anonymous parameters. Oh, this is a small RFC. Currently, Rust allows anonymous parameters in trait methods. So if you have trait, RFC proposes to deprecate this syntax. Intentionally does not propose to remove this syntax. Historic accident. Because number of technical enhances, surprising patterns, syntax, and traits. So, okay. This is, I think, I really don't know what this means. Patterns more complex and this inconsistent with default implementations. In traits and implementations in implement IMPL blocks. Anyway, coming back, I think this is like an error. So we can't do that. We have to mention. So if this is a self type, give it a parameter name. If this is a parameter name, give it a type. If this is a type, explicitly ignore the parameter name. Okay. Is it? So can I just, no, I don't think I can access invalid argument, right? So this is basically, I don't care what the parameter is. Just pass in whatever. Interesting. Um, in function signatures, you must declare the type. This is a deliberate decision. Requiring type annotations means the compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. More helpful error message if is knows. Defining multiple parameters, separate the parameter declarations with comma, like this. So you have 5, okay, and measure, okay. This example creates a function print labeled measurement with 2 parameters, its value. Fine, yeah. Statements and expressions. This is, I think, a statement which ends at semicolon. Expressions, yeah. Statements do not return values, therefore you can't assign a let statement to a variable. as the following code tries to do, it will give an error. Okay, yeah. So this I'm trying to evaluate, doesn't happen, nothing happens. Yeah, let's just try to do that and see how the compiler guides here. Okay, a lot of things. Found statement let, variable declaration using let in a statement. Let expressions in this position are unstable. Okay, for more information. Yeah, explain me Rust C. Oh shit. Reaper U128, if we're using stable beta version. Okay. Let expressions in these positions are unstable. Let x is equal to y is 6. Unnecessary parentheses have an assigned value. Okay. For more information about this error, try Rust C explain. Functions can return values to the code that calls them. We don't name return values, but we must declare their type after an arrow. In Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of the function. Okay. We don't name return values, but we must declare their type after an arrow. Okay, something like this. The return value of the function is synonymous with the value of the final expression in the block of the body. You can return early from a function by using return keyword, specifying a value, but most functions return the last expression implicitly. That's also, I think, similar to Scala in some sense. Function 5, I32 is return 5. Okay, correct. It will run 5 plus 1. It just says x plus 1. Yeah, why won't this run? What is happening here? So I say plus 1. Oh, is it because there is a semicolon after that? I32 found empty. If I remove this, that works fine. Okay, what if about this? Admitting operation produces a value. To ignore the resulting value. Okay. Oh, okay, okay. Yeah. It doesn't allow me to ignore that. Okay, so now if I run this, I should just get 1. Okay. So a few important things. Implicitly returns the last statement of the function. Does not allow to, if a statement returns an operation, you have to do something about it. Either the function will return on your behalf or you have to exclude it. Like, I don't care, just put it some sync, that kind of way. Nice. Comments, I think this is pretty fine. I guess like VS Code already sort of supports that. Like, so comments are fine. Yeah, is there only one type of comment? Let's try to make the code easy to understand. Extra explanation, leave comments. Oh, okay. Control flow. Yeah. Yep. Yep. Um, this. Okay. No brackets. So we just have number less than 5. Okay. expression. Match expression, I think we tried in a matching game. The match expression, that is another control flow. Um, if number, yeah, let's see what is this. Everything I think I'm just modify the same. So it's a bool. Oh, it can't do anything. Um, what if? Unnecessary parentheses around assigned value. Remove these parentheses. Okay. Hmm. Oh, I'm able to run here also. Nice. Handling multiple conditions with else if. So we have this and then else if. Using if in a let statement, because if is an expression, we can use it on the right side of a let statement to assign the outcome to a variable as it lists in 3 2. Condition true, number if condition 5, else 6. Number of the value of the number is number. Loops. Yep. So I think loop, we had seen this kind of a while loop operations. What will happen? It doesn't allow to run, but so let me try just to uh, write a loop here on my own. Right, that will go into an infinite loop option, which I don't want. Let me say mutable variable I, which will start from 0, and I'll say if I is greater than, or if I is equals to 10, how does the if condition looks like? It did not have anything, it's just say break, and then I'll do a println, and I'll just print the value of I. After that, I'll increment I if that is allowed. So there are a lot of things I'm trying to test here. Let's see what it says. Yeah, of course it should be I equals I plus plus is not a valid postfix, so okay, this is fine. Must be a string literal, so this is not a string literal, so I think something like this should work. Yeah, so now if we run this, we got a loop value. So that's essentially our strongest construct we have here is a loop. We can potentially do like a FizzBuzz program now, but we'll see. So if number, if condition, then 5, okay. So if is an expression, we can use it on the right side of the let statement. Okay, yeah, I guess we have repetition with loops. So what are the things we have? We have loop, while, and for. Loop keyword tells execute a block of code over and over until you explicitly tell it to stop. Sure, and that's like an infinite loop, while true kind of thing. Once or one of the uses of loop is to retry an operation you know might fail. So, oh, interesting. Loop returns a value. Okay. Break counter. Okay, so I can return a value there. Before the loop, we declare a variable named counter, initialize it to 0, declare a variable named result to hold the value written from the loop. This is really powerful. Loop labels to distinguish between multiple loops. If you have loops within loops, break and continue apply to innermost loop. At that point, of course, you can optionally specify a loop label. So, okay. Mhm. Interesting. So the counting up loop, println count remaining. Uh-huh. So initially count is 0 and that's the what will print. Remaining is 10. If remaining is 9, otherwise remaining will reduce. If it's 9, it'll just break out of it. Then it'll increment again. Um, increment again. Then it'll go inside if remaining is 9. No, let me see. So if first I think will come here, then remaining is 10, remaining will be 10, remaining is not 9. We'll go here, remaining is 9. Will break, come here, count will be 1 now. So we'll go inside, count is 1, and that will be printed. It will go here. What is remaining? Remaining is now 10 because every time next time you go, you want 10 now. So print remaining 10 and count is 1, remaining is 9. It'll go here, break out. So count. Okay, so we are basically alternating, like not actually alternating. Um, we are going out. I mean, it's a complex nested operation. I I don't know. Personally, I feel like this is like really complicated to understand, and if there is any value of doing something like this. But probably, if the language is provided, there might be some people who find this interesting. While loop, yeah. So that's I think uh, quite interesting. Awesome. So we have println number -1. And we do lift off using a while loop to run. The construct eliminates a lot of nesting that would be necessary. Looping through collection with for, you can choose to use while construct to loop over elements. Cool. The value is 10, 20, 30, 40, 50. Okay. Hmm. Okay. And okay, yeah, I guess like the for loop for it's a very small thing for something like this. Okay, element in. This is nice syntax. We can also provide something like this number in this. Hmm. The code is very nice. Yeah, it's nice. This was a sizable chapter. You learned about variables. Yeah. So we are at the end of chapter 3. Okay. Yeah. So we have learned something. I guess like this is sufficient for today's stream. So we have learned a lot of things today. We till the last point we sort of did a programming of the guessing game, which had some of these concepts like loop, match, and stuff. But this time, I think with variables, data types, functions, control flow, that is, I think, a good fundamental understanding is required, which we had from this. Seems like a good segue to end the today's session. In the next session, we'll start with understanding ownership about trust. Thanks for tuning in. See you in the next session. Bye bye.